Okay, so we will talk about elliptic curve over real, then we talk about elliptic curve over ZP. Okay, so basically the definition is we take two real number AB such that for a cube, this is the non-singularity condition of an elliptic curve, b square is not equal to 0. Okay, then we take this equation y square equal to x cube plus ax plus b for this AB, and this will give us a elliptic curve over R. So, the collection of the points this x y such that this and ABs are coming from R such that this condition 4a cube plus 27b square is not equal to 0. So, this collection, this is a elliptic curve along with a point which is called point at infinity. So, this is denoted by, this is called, we will talk about what we mean by point at infinity. Point at infinity. Okay. So, this is a this curve is called elliptic curve over R along with this point at infinity, and this condition we require in order to have, this is called non-singular elliptic curve. And if this is 0, then that is if 4 a cube plus 27 b square is 0, then it is called singular elliptic curve. Singular curve, and this is coming from the, I mean, this is the extremum. I mean, like if we take the partial derivative of this, if we take this this side, then it is a function of f x y. So, if you take f x f y equal to 0, this will give us this solution. So, it is the extreme point condition. So, to have the three real roots of this equal to something, we need this condition to satisfy. So, this will ensure that we have third point of intersection with the curve. So, let us draw the curve. Okay. Let us draw the curve, and let us define a addition over operation over this elliptic curve points. So, let us draw the curve. So, suppose this is x axis, this is y axis, and our curve is y square equal to x cube plus ax plus b. This is over real. So, if you draw, it has two part, this and another part is this symmetric. So, if you draw this equation y square equal to x cube plus ax plus b, where we have this non-singularity condition of on the AB, that means we choose AB such that 4 a cube plus 27 b square is not equal to 0. Okay, so this has two part, this one and this one. Okay, now how we defined a addition? So, let us take 2 points on the curve PQ. So, this is P, this is Q. Let us take 2 points PQ on the curve. So, now let us draw the line joining PQ, and suppose it is touching another point R in the curve, and we take the mirror image of R with respect to x axis, and this is basically r prime, and this we defined as p plus q. This is how we define the addition over 2 points p q. So, we take any 2 points p q, it could be 1 point is here, 1 point is here, but for simplicity to visualize, we are taking 2 points on here, and we join this we join the straight line, we draw the straight line joining p q. So, it is touching the third, this is the third point of intersection with the curve with this line, and if we take the mirror image on this based on the x axis, and that is our r prime, and that is how we define p plus q, this point. Okay. So, now we want to know the coordinate of this p plus q. So, suppose this is p is say x1 y1 and q is say x2 y2, and we want to know what is p q. Say this is x3 y3, and so this will be then, so this is the mirror image of this. So, x3 minus y3. So, this is just the mirror image based on the x axis. Okay. So, now how to define this, how to get the, so there are 3 cases. Case 1 is if x1 is not equal to x2, I mean if pq are same, and if x1 is not equal to x2, pq are different, and if x1 is, so there are 3 cases basically. Let us just write the cases, we will come back to this picture again. Okay. So, case 1, okay, if x1 is not equal to x2. Okay. So, in this case, so this is say this is r prime, or we can, yeah. So, this is basically x3 y3. Then how we calculate x3 y3? We can take this line, and slope of that line is basically lambda is equal to y2 minus y1 by x2 minus x1. This is the slope of the line, and the equation of this line is y minus y1 is equal to lambda into x minus x1, and this line is passing through this point. So, that means, so this is the equation of the straight line, and since x1 is not equal to x2, this will be a chord. So, this is perfectly okay. So, the slope of this line is y2 minus y1 by x2 minus x1, and this is the equation of the line, and now this line is passing through this. So, if you put this value, we are getting basically minus y3 minus y1 is equal to lambda into x3 minus x1. So, from here we can just write y3 is equal to, so y3 is equal to, so we take y3 is equal to, we take this side lambda into x1 minus x3 minus y1. Okay. So, this is one equation based on this y coordinate. So, this is involve x3. Okay. So, now how to get this x3? Now, if we put this value y in this equation, so this is basically y is basically y1 plus lambda into x minus x1. This is y. Okay. Now, this is passing through this curve x3 plus ax plus b. So, we can just put this value y over here, y1 plus lambda into x minus x1 square is equal to x3 plus ax plus b. So now this is a cubic equation in terms of x. So this is basically, this is x3. Now this is x3 and then some term will be in x square. So this lambda into x square. So if we take this lambda this side, so this will be basically lambda square x square then plus some lower order term equal to 0. So this is a cubic equation in x. So it basically has 3 roots, and these roots are basically, one is x1, another one is x2, another one is x3. These roots of this cubic equation. There are some terms, if we just simplify this, we will get the other terms, lower order term. So this is x square, because this will give us x square. So there is no x square over here. So if you take this side, it will be minus lambda square x square. So this is the cubic equation in x, and so cubic equation means it has 3 roots, and these roots are basically x1 excuse me, x1, x2, x3. So we know sum of the roots is basically minus b by a. So that will give us, so sum of the roots x1 plus x2 plus x3 is basically minus this by 1. So this will give us lambda square. So that means x3 is basically lambda square minus x1 minus x2. So lambda square minus x1 minus x2. This is x3 and this is y3. Okay. So this is x3, this x3, and this is this x3, and this is y3. So this is the coordinate for the r, the plus p plus q. If p q are, if p q are not equal, and p is not equal to minus q. Okay, so this is case 1, or lambda is this one. This is case 1. Now case 2 is telling us, so this is okay, na? Yeah, so we can write case 2. So case 2 is basically where x1 is x2 and y1 is minus y2. So how it is looks like if x1 is x2 and y1 is minus y2. So that means, so let us just rub this. So this is the curve we have. So this is case 2. Okay, so this means p is here, p is x1. Yeah, so x1 this, and q is basically telling us q is x2 and minus y1. So this is parallel basically. This is x1 minus y1. So this is parallel. So parallel to other part of the curve. So then where is the third intersection? Because third intersection is the sum. So here is the third intersection. So third intersection will be, we assume this is at the point at infinity. So that's why we take for this case p plus q is, we define this symbol which is called point at infinity. Point at infinity, as if they are meeting at infinity, because they are parallel to the other part of the curve. So this is third point of intersection is as if point at infinity. So this we so this is basically this q is basically minus p. So then p plus of minus p is basically this. So later on we want to see whether this is along with this E, the elliptic curve. So E along with this will form a group or not. So for that we need to have the inverse. So basically and this is the identity element. We'll talk about that, but this is the addition when P is equal to Q is equal to minus P. So they are meeting at the point at infinity. So this is case 2. Now case 3, when they are same, when PQ are same. Okay, so when PQ are same, when x1 equal to x2 and y1 equal to y2. So in this case, so this is P and this is also Q. So this is also x1 y1. I mean basically both points are same. Then it will be a tangent. It is meeting here and this is the other part of the curve. So this is R and this is R prime, which is P plus Q. Now we denote this x3 y3. Okay, so this is basically P plus Q actually, P plus P, both are same. So in this case, so what is the x3 y3 then? X3 is basically, we know x3 is lambda square minus x1 minus x2, but x1 x2 is same. So it is basically lambda square minus 2x1, and y3 is basically, I mean the straight line equation from here we are getting x1 minus x3 minus y1. Okay, and here lambda is basically slope of this line. So this is a tangent, so slope will be dy dx. So equation is y square equal to x cube plus ax plus b. So if you do the 2 dy dx, 2y dy dx is equal to 3x square plus a. So dy dx is basically 3x square plus a by 2y. Okay, so dy dx at the point x1 y1 is basically 3x1 square plus a by 2y1. So this is our lambda for this case, because this is a tangent. So lambda here is 3x1 square plus a by 2y1. Okay, so this is basically P plus Q, and so if you combine this, and we can write this. So there are 3 cases. First one is PQ are different, so it is a basically straight line, it is a chord, and the second one is their PQ is equal to minus P, then they will meet at point at infinity, and third case is, this is the case number 3. So third case is when they are same. Okay, so let us just summarize this. If P is equal to say x1 y1 and Q is equal to x2 y2, and how we define the sum? We define the sum in this way. If Q is equal to minus P, then the sum is, which is basically P plus or minus P. This is basically theta, this is point at infinity, and if P is not equal to minus Q or Q is not equal to minus P, then P plus Q we denoted by coordinate x3 y3, where x3 is nothing but lambda square minus x1 minus x2. This is coming from the sum of that 3 roots, and this y3 is equal to lambda into x1 minus x3 minus y1, and where lambda is basically lambda is basically if it is a chord, then lambda is y2 minus y1 by x2 minus x1 if p not equal to q, and if p is equal to q, then it is a tangent. Then we have 3x1 square plus a by 2y1 if p is equal to q, then it is a tangent. Okay. So, this is the formula for finding the p plus q. Okay. So, now this plus operation we defined over this elliptic curve points. So, we have a elliptic curve E, which is basically set of all points such that this is coming from r square, r cross r, x y. This is elliptic curve over r. Okay, so such that y square equal to x cube plus ax plus b, where a b are coming from r, such that that non-singularity condition 4a cube plus 27b square is not equal to 0, along with a symbol which is called point at infinity. So, this along with point at infinity. So, this so this set, this is a set of the points, elliptic curve points. So, this set along with this operation plus, which we just now seen, the question is whether this will form a group or not. So, whether this is forming a group or not, in particular whether this is an abelian group or not. So, it can be proved that this is an abelian group or commutative group, abelian group. Okay. So, if it is an abelian group, so to prove that we need to for group we need to have a closure property. Closure property means if you take any 2 points p q from this, so p is equal to x1 y1 from this set E, and if you take another point x2 y2 from E, then p plus q should also belongs to E. So, closure property is okay. Now, the second property for group is associativity. So, associativity means if you take 3 points p q r or p q s, p q r from E, then we must able to see that p plus q plus r should be same as p plus q plus r. So, this is called associativity property. Okay. So, and this must be true for all PQR. Then we have a, and this also can be proved geometrically. This is not very straightforward, but it can be proved. And then the third should be the existence of identity element. So, who is the identity element? This phi is the identity element. Phi is the identity element. Hey, sorry, this phi means point at infinity. This is the point at infinity. infinity. So, this serve as an identity element, that means p plus this is p, and this is true for all p belongs to E. Okay. So, this is the things, and the inverse. So, this is the identity element and the inverse. So, each element should have inverse, that is another property for a group. So, each element should have inverse. So, such that if we do the operation on that inverse, it should give us a this group. So, identity element. So, for each p we have, so this is the inverse. So, identity 4 is inverse. So, for a p which is say x1 y1, then we have q which is basically minus p, which we are telling the x1 minus y1, such that we know that p plus of minus p which is identity element. So, this is the inverse. So, every element has the inverse. Okay, and this is also we are telling abelian group, that means it is commutative. Commutative means p plus q should be equal to q plus p. This is quite obvious. So, this will form a group. So, this group this is coming from elliptic curve point. So, E along with this is an abelian group. Okay. So, this is over R. So, in next class we will talk about how we can get these points over ZP. Okay. Thank you.